Right. So we'll start. We'll start today from logarithms and go ahead on to good evening. Right. So we'll start from logarithms and go ahead on to dimensions and the derivations and correctness. And we'll first take the homework as well. Right. First, we'll get with this basic maths part over it. So then we only have to do the graphs next week. No? So logarithmic expressions. So this part is quite easy. We'll try to do almost all the sums. So the common equation is log b, yeah, I can take log b x is equal to y. Right? So what this means is that y is the power of b. B to the power y is equal to x. So what it means that log bx, what you are going to get when they say log bx is b to the power of something is x. So they are asking you to find that power, right? So the answer of a certain log value is actually a power, right? So this is the common equation that we will need to use in all our sums, right? Okay, let's do the first one. We'll quickly go through this. It won't take much time. You can send the answers in the chat. Yes, one of you has have sent the correct answer. So you can divide 81 by 3 and see. So you get 2, 6, 21, then you get 7. So 27 is again divisible by 3. 9. No? So 9 is again divisible by 3. That's 3. 3 is divisible by 3. So how many 3s are there? 3 into 3 into 3 into 3. So essentially this should be divided like this. 81 divided by 3, that's 27. Divide by 3, 9. Divide by 3, 3, 3. So you get 3 times 3 to the power of 4. So log 381 is equal to 4. 3 to the power of 4 is 81. So this power is what's the simplified answer for log. Do the second one. Yes. One of you have sent the other answer as well. You can do it pretty quickly. This is easier than trigonometry. Yeah. So two of you have sent the answer. No? Others also sent while I am doing. So 256 divided by 2 is 128. Divide by 2, 64. Divide by 2, 32. Divide by 2, 16. Divide by 2, 8. Divide by 2, 4. Divide by 2, 2. Divide by 2, 1. So 1, 2, 3, 4, 5, 6. 8 twos. Yes, all of you have said the correct answer. Great. So it's 8 twos, that's 2 to the power 8. So log 2, 256 is equal to 8. Next one, log 10.001. So although we just do like the uh, log 3s and log 2s here, and log 4s and 5s are also there, like in the exam, what we use for the logbook is the log 10, right? And instead of log 10, you can write that as LG as well. Instead of this expression, you can use LG. You can't use that for other log values, like for the powers of 2 and 3 or any other value. You can't use that. You can only use it for 10, right? Right, nice. So everyone has sent the correct answer. Do the third one. Yeah, one of you has said the correct answer. What's the answer for the third one? It's not that hard. That's also you have to get the power. Yes. Yeah. So almost all have sent the correct answer. Check that the answer is correct. So log 10.001, right? So 001, you can write it in terms of a power, no? Log 10, 10 to the power minus 3, right? So the power for 10, you can, it's complicated to write it like that. So 10 to the power something is equal to 0.001. That is 10 to the power minus 3, no? 1, 2, 3. So finally x is equal to minus 3. That means the answer for this is minus 3. I mean, you can take it directly. I just showed you so that uh, you will know how it comes. The answer is minus 3. Fourth one, Yeah. Some of you have sent the correct answers, some sent a different answer. So here 4 to the power something should be equal to 1, right? 4 to the power 1 is 4. So any power, right, to the power of 0 is 1. So here answer is 0. 4 to the power 0 is equal to 1, right? 4 to the power 0 is 1. Fifth one, yes. So everyone has, ah, almost everyone has given the correct answer. So log 5 to the power something is 25. So 5 into 5 is 25. Huh? So 5 to the power 2 is 25. 5 to the power 2 is 25. Next, the other side first. That don't do. That don't do. You need log tables and stuff. No? This just cut off the question. That's not possible to do without any help, right? This, do the second one. Yeah, it's the same answer, no? Minus 3, right? It's minus 3. So 1 over 1000 is 0.001, right? So it's the same as this, no? So the answer is minus 3, right? Then when we come to the addition of logarithms, addition and subtraction of logarithms, let's say log, their bases should be the same, right? You can't add them otherwise, right? Yeah, it should be either in the 6, right? Here it's 6, here it's 3. They should be the same. If it's 10, it's 10. Then when two values are getting added, let's say log 10a plus log 10b, you can actually get the multiplication of it. Log 10a into b, and then get the uh, power for that multiplied value. And when it's a subtraction, let's say log a minus log b, that is a division. When you write them together, it is a division. Log a over b, right? So now this is minus log 6 36 divided by 6, right? So you get log 6, 36 divided by 6 is 6. So 6 to the power 1 is equal to 6. So its answer is 1, right? Answer is 1. So the fourth one, yes, it's log 9 plus 3, right? Log 9 into 3. That's, sorry, log 3, 9 into 3, that's log 3, 27. So it's log 3, 3 to the power, so log 3, 23 to the power, 3 into 3 is 9, and into another 3 is 27. So 3 to the power 3 is 27. So it should be 3. 3 to the power 3 is 27. The last one also? This is half, 8 into half. Yeah. So it's log 2, 8 into half. That's log 2. So 8 into half is 4. Log 2, 4. 2 to the power 2 is equal to 4. Answer is 2. You can do the first one as well, right? You can do the first one. See what you get. It's a bit different from all the other questions. Log 2.125. Yes, one of you has sent the answer. Now, 0.125 is something which is less than 2. So it can't be 2 to the power 1. No? 2 to the power 1 is 2. So it has to be something less than that. Then most probably it will be negative power. Yes, so we'll see. Two of you have sent the correct answer. Yeah, and three of you have sent the correct answer. So log 2.125. So 2 to the power x is equal to 0.125, right? So it should definitely be a negative power. So what is 0.125? That is 125 over 1000, right? That is 1 over 8. 2 to the power x is equal to 1 over 8, right? X is the answer that we are coming here. 1, 8 is 2 to the power 3. 2 into 2 is 4. 4 into 2 is 8. 2 to the power x is 1 over 2 to the power 3. Then 2 to the power 3 comes up, it becomes 2 to the power minus 3. Right? So it's x is equal to minus, right? So another way that you can write expressions is if you have something like log 10 and x to the power a, you can take this power to the front and write a log 10x, right? That is what they have done here. For example, half log 36 means log 36 to the power half. Power half means it's the root of 36, right? Log root 36, right? So you get log 6, that's you need to get the logarithm book for that, right? So here also similar to that. 2 log 10 is actually log 10 to the power 2, that is 100. Minus log 2 means divide by 200 divided by 2, it's 50, then you get the log value for 50 from the log. Okay, so for these, you need the logbook. Do these for homework, right? It's just some practice questions. We'll do this one for now. Yeah, let's do the first one. We'll do the first one. We'll do around 4 sums. First, we'll do the first one. Log 3 plus log 12. You can either take them separately or you can take them after multiplying. Easiest would be to like multiply and take. So for an example, I'll show you just to remind you how to get log. So let's say log 20. Oh no, log 2. Log 2, that is log 10 2, you don't need to write 10. Log 2 you can write as, so 2 is, we have to take it in, like first write it in standard notation, right? 2 is 2 into 10 to the power, like it's something 0 point something, no? Because it's less than 1. 10 to the power 1 is 10 and it's not 0 either, so it's in between 0 and 1. So 2 doesn't have a 10 to the like a whole number power. So first start off with 0. This is the 10 to the power that that number can be written in standard notation. 0 point, then you have to search for, like logbook has this value, no? Wait, I'll just download a logbook and tell you. Easy. Here I wrote the logbook. Yes. So log 10 2. That's what we are finding. So 2 is not like there's no 10 to the whole number power. So you start off with 0 point, then you search for 2 from this column. From this column you search for 2. You first find it here, it's 20, but it's 2, right? So 0 point, this is the value, right? In the 0 column, because if it was 21, they have to take this value. If it's 22, it's like that, right? So 3010. 0.3010. That's the answer. So this is the power, right? 10 to the power 0.301 is 2. Then if it was log 220, it should be now 20 can be written as 2 into 10 to the power 1 point something. No? Like it can be written as 2 into 10. So you can start off with 1. There is 1 power for 10 and then it's just 2 writing in log form. So 1 point, this is 2, no? 3010. Then if it was 200, you get two zeros. So write 2 first. That's the amount of zeros there. Zero in the sense amount of decimal places, right? Amount of 10 to the powers, not decimal places, 10 to the powers when you write it in standard. So 2 point, then like it's 2 into 10 to the power 2. So this 2 you have to write it as 3010 again, right? That's how you get the log value. So what's the first sum is log 3 plus log 12, no? Log 3 plus log 12. So, sorry, this 3 and 12 should be like whole numbers. So it's log 3 into 12. Then you get log 36. Find out where what the answer is for log 36. right? So log 36 can witness 3.6 into 10 to the power 1. So it starts at 1 and then you go to find 36 from it. So here is 36. 3, 6 and 0. 5, 5, 6, 3. So we get 1.5563. That is the answer. Yes. None of you have sent it. Do the next one, log 100 minus log 4. I'll keep the logbook open because I feel like you don't have any logbooks with you. Log 100, 100 is here, minus log 4. Yes. So it's log 100 divided by 4. That's log 25. So it's 22.5 into 10 to the power 1. So 1.25. Find out 25. Here is 25. 3979. No? One of you send the correct answer. 3979. Okay. Yes, two of you have sent the correct answer. Let's do the third one as well. Half log 36 plus log 2. Half log 36 plus log 2. Yes. So half log 36. Half is the power of 36 now. Log 36 to the power half plus log 2. So power half means it's the root, right? Root means power half. So log 36 plus root of 36 plus log 2. So log root 36 means log 6 plus 2. So we can just multiply 6 by 2 now. So it's 12, no? Log 12. What is log 12? Log 12 is 0.792. So 12 you can write as 1.2 into 10 to the power 1. So this 10 to the power 1 is what's our log number is starting with. 1.0792. That is the answer for this expression. Right? 1.0792. Yes. Okay, we'll do one more before going to the lesson. Let's do the seventh one. 1/3 log 64 and half log 81. 1/3 log 64 plus half log 81. No? Was it 81? Yeah, half log 81. 'Yes, who of you have sent the correct answer? So get the power for both of them. Log 64 to the power 1/3 plus log 81 to the power half. So 64 you can write as 4 to the power 3. 4 into 4 is 16. 16 into 4 is 64. So 4 to the power 3 into 1/3 plus log 81 you can write in terms of 9 into 9. So 9 to the power 2. It's actually the root of 81. So you can, if you don't understand it that way, you can write this way as well. So 3 and 3 gets cut, 2 and 2 gets cut. So it's essentially log 4 to the power 1 plus log 9 to the power 1. So it's 4 into 9. Log 4 into 9, that is 36. 36 you can write as 3.6 into 10 to the power 1. So it's the answer for this is 1.36 is here. 5563. 1.5563. Okay, no? We'll go to homework from the last day. No? So next day we will be doing graphs. There's nothing much in graphs. Okay, so okay. So I gave for homework, I think. The so just tell me if these are the homework questions I gave from here to second one, seventh one. Or did we do seventh one? Then 11, 12, 14, 15, and 16. Are these the homework questions, or are there any questions among these that we already discussed, like last week? These are no. So I'll first start from the second one. We can move through that quickly. 1 meter per second going into kilometer per hour, right? Kilometer per hour. So meters to kilometers, it's 10 to the power minus 3 kilometers. No, 1 meter is 10 to the power minus 3 kilometers. And 1 second is how many hours? One 1 hour, right? 1 hour is 60 minutes. Each minute has 60 seconds. So 1 hour is 3600. That's 60 into 60 seconds. So 60 into 60 is 60 into 6, 36. 3600 seconds is 1 hour. Then 1 second is 1 over 3600 hours. Yes. So per second, right? Per second. That is the other way. So this is 1 second per seconds. 1 per second means 3600 comes up, right? This is 1 over 3600. So it's easier when you put directly, it's like per second means divide by 1 second, right? So instead of 1 second, you can put 1 over 3600 hours. 1 over 3600 hours. Okay. So you actually multiply it by 3600, no? Here 3600 comes up. So 1 into 10 to the power minus 3 into 3600. That's kilometers per hour. So 10 to the power minus 3 and 3600 is 3.6 kilometers traveled in 1 hour when your speed is 1 meter per second, right? Here the conversion is not just about the tens and 10 to the powers. Here there's a bit of a numbers involved as well, right? So you can like cross multiply this and get 3600 per hour is equal to like 1 second comes down, 3600 goes up. So per second, right? And substitute directly 10 to the power minus 3 kilometers into 3600 per hour. Okay, right. That's the second one. Then the seventh one. What was the answer that you all got for the seventh one? 6 farads per volt. So you all don't need to know the units, what it means. You need farads and volts in electrostatics, and that should be converted to microfarad into nano per nanovolt. Microfarad per nanovolt. Did you get as the answer for this? So it's 6 into farads to microfarad. So 1 farad is 10 to the power 6 microfarad, right? Farad to microfarad. Per volt to per nanovolt. So 1 volt is 10 to the power 9 nanovolts. Then 1 nanovolt is other way around. 10 to the power minus 9 volts is 1 nanovolt, right? So when it's per, no? So divide by 1 volt, right? Divide by 1 volt means it's 1 volt is 10 to the power 9 nanovolts. So it's actually 10 to the power minus 9 per nanovolt, right? Here it's a big value to a small value. So it's 10 to the power 9 minus. Okay, so you get 6 into 10 to the power minus 3 microfarad per nanovolt, right? Then we go to the 11th one. What did you get for the 11th one? Yes, can you send what you got for the 11th one? So it's 400 newtons per square meter going into giganewtons per millimeter square. giganewtons per millimeter square. So newtons to giganewtons, there's a small number to a large number, so it should be 10 to the 1 Newton will be a lesser number of giganewtons, right? 10 to the power minus 9. Meganewton is 10 to the power 6, then giganewton is 10 to the power minus 9 giganewton. Meter per meter square to millimeter square. Now, 1 meter is 10 to the power minus 3, 10 to the power 3 millimeters. 10 to the power 3 millimeters. 10 to the power 3 millimeters. And that to the power minus 2. So you get 400 into 10 to the power minus 9 into, here it's 10 to the power minus 6 giganewtons per millimeter square. So, sorry, here should be minus 9. So minus 6 and minus 9. So that will be minus 15 and here plus 2. Minus 15 plus 2, no? Minus 15 plus 2, minus 30. Here 2, no? Minus 9, minus 6. So it's 10 to the power minus 30 giganewtons per millimeter square. Twelfth one, what have you got for it? Let's see. Twelfth one, 1000 kilograms per cubic meter. That's actually the density of water. 1000 kilograms per cubic meter going into micrograms per cubic centimeter. So kilograms to micrograms, that's a very big value. So kilograms to grams is 10 to the power 3, right? 1 kilogram is 10 to the power 3 grams. And then grams you have to convert to micrograms. So 1 gram is 10 to the power 6 microgram, right? You'll only get one MCQ out of this whole lesson. But uh, like you need to learn how to convert, no? So for all the questions, there is conversions, unit conversion. So there's millimeter per millimeter square to millimeter square. So conversions are there in all lessons, right? This is a basic lesson where it is required in every lesson. But directly from dimensions as question, you get the first MCQ from this lesson purely. But all the theory that we do here, you need it for all other lessons, right? It's kind of spread into every other lesson. It's units, no? So they are used in all other lessons. Here we are converting grams to micrograms, right? Micro is 10 to the power minus 6. Like last week we discussed this, but I'll say it again.
right? Since it's 1 gram, there are many micrograms. No, microgram is just one small value. So there are 10 to the power 6 micrograms in 1 gram, right? If it was the other way, 1 microgram to gram, then that's 10 to the power minus 6 grams in 1 microgram, right? So here I can convert centimeters. So 10 to the power 6 microgram into per cubic meter. So per cubic meter to per cubic centimeter. That is 10 to the power minus 2, 1, sorry, not minus 2, 10 to the power 2. 1 meter is 10 to the power 2 centimeters, right? 100 centimeters is 1 meter. But it's now per cubic meter. So you get 1000 is 10 to the power 3. This is 10 to the power 3. So this becomes 10 to the power 9, 3 plus 6 microgram into 10 to the power minus 6, no? 2 into minus 3. Here this becomes per cubic centimeter. Then it is here 12, 9 plus 3, 12 minus 6, 10 to the power 6 microgram per cubic centimeter. Okay, then we go on to 14th one. Yes, right. 14th one, 5 into 10 to the power 6 joules per second per square meter going into millijoule per millisecond per square centimeter. So there are 3 units now we have to consider. 5 into 10 to the power 6 joules to millijoule. 1 joule to millijoule is 10 to the power 3 millijoules. Per second to per millisecond. 1 second is 10 to the power 3 milliseconds into 10 to the power 1, this one. Then per square meter to per square centimeter. That is meter to centimeter is 10 to the power 2 centimeters to the power minus 2. So you get 5 here, you get 10 to the power 9. Since we have substituted the units, you can write the units at the end. Here 10 to the power 3 to minus 1, that's 10 to the power minus 3. Here 2 into minus 2, 10 to the power minus 4. So 5 into 9 minus 3, 6. 6 minus 4, 2. So it's 500 millijoules per millisecond per square centimeter, right? Next we have the 15th one. 15th one. 1 joules per second per square meter going into terajoule per nanosecond per megameter squared. So there are, you won't get units like this, like anywhere else, right? It's just for practice. Okay. So even I don't remember what tera is. You have to remember what tera is like, what the prefix of tera is. Tera is 10 to the power 12. That's after giga. So 1 joule to 1 terajoule. Terajoule is very much bigger than a joule. So it's 10 to the power minus 12 terajoules. Second to millisecond. So, sorry, nanosecond. There are many nanoseconds in 1 second. So 10 to the power 9 nanoseconds in to the power minus 1 per meter square to megameter, mega square megameter square, right? Per square megameter. So meter to megameter, that's 10 to the power minus, yeah, 1 meter is 10 to the power minus 9 megameters. And that into per, per megameter square, right? So what we get is 10 to the power minus 12 into 9 into minus 1 is 10 to the power minus 9 into minus 9 into minus 2, that's 10 to the power minus minus becomes plus 18. No? Here 8 minus 12 minus 9 is minus 21 plus 18, that's minus 3. So you get 10 to the power minus 3 as the final answer. Terajoule per nanosecond per megameter square, right? Okay. Then 16 one. 12 meters per square second going into kilometers per square minute. Yes. So here also there's a value that's coming here, seconds to minutes, right? So 12 meters to kilometers. 1 meter is 10 to the power minus 3 kilometer. And 1 second is how many minutes? 1 over 60 minutes. No? So 60 seconds is 1 minute. 1 minute. Then 1 second is 1 over 60 minutes. What you get is 1 second is 1 over 60 minutes to the power minus 2. Right? So 12 into 10 to the power minus 3 into here 1, this becomes 1 over 60 to the power minus 2. Then take it up, it becomes 60 to the power 2. Right? So 60 to the power 2 means 60 into 60, that's 3600. 12 into 10 to the power minus 3 into 3600. So it's essentially this can get cut and this becomes 3.6. 3.6 into 12. 72, 36. So 2, 13, 432. 43.2 kilometers per square minute. I mean, kilometers per square minute is like some sort of acceleration or something. Right. So those are the homework. There's another homework. No? I gave exercise 3 also. Right? We did 1 and 2, I think. Did we do 1 and 2? Right. Okay, from 4, right? We start from 4. So, so we are starting from 4, 6, 8, 9, 10, 11, 12, and 13. Then I gave 14, 15, 16, 17, 18. Oh my God, I've given a lot now. 14, 15, 16, 17, and 18. Right, right. We'll start from 4 then. Can you all hear me? Right. So, fourth one, F equals G M1 M2 over R square. So F is a force, M1, M2 are masses, and R is the distance. They're asking what are the units of G. So F is a force. We know that units of force is kilogram, meters per square second. Right now, follow the laws. These two you're writing together, but there are small spaces in between kilograms and meters and seconds. That is equal to G. That's what we are going to find. For M1 it's kilogram and for M2 also it's kilogram. Divide by R is distance. Distance is in meters. Then meters square. Now substitute for G. Meter squared gets multiplied with meter. It becomes cubic meter. Kilogram, one of the kilograms gets cut. It's dividing now. And the other kilogram goes to the denominator of the other side. So it actually becomes per kilogram when it comes up. Seconds per seconds remains the same. So you get cubic meter per kilogram per square second as G. Right. Sixth one, Q equals mc theta. Q is heat. So in our first and second questions, we did about energy and like joules, no? So Q is heat, that is a form of energy. So energy is kilograms meter square per square second, right? You can take these units from the previous questions. That is mass m is in kilograms. C is what we need to find. Theta is temperature change. So it's either in degrees Celsius or degree Kelvin, right? Per Kelvin, oh, sorry, degrees Kelvin or sorry, degrees Celsius or in Kelvin. Either one, it's okay because change of 1 Kelvin is equal to a change of 1 Celsius. We did that last week, no? So you can take it as per Celsius even, not per Celsius. Easier to take it in Kelvin, no, because we have to find C again. So kilograms get cut with kilograms. The Kelvin goes to the other side. You get meter square per square second per Kelvin equals C. When this goes down, it's divided by K. That K goes up, it's per Kelvin. So we did the seventh question. We have to go to the ninth one? No, no, eighth one. So eighth one. V equals U plus AT. They are asking, saying V is the velocity, U is the initial velocity, and A is the acceleration, T is the time. What are the units of A? So we know that as a principle, the separate expressions which are added on either sides of the equation should have the same units. So the units of V should be equal to the units of U, and they should be equal to the product of AT. So what's velocity? That's meters per second, no? And that should be this A into T. A is acceleration. They are asking us that. T is in time. So A into seconds. So seconds go to the other side, right? M is minus 1 over S equals acceleration. So that's ms minus 2. Okay. Yes. So we can do the ninth one. In P equals mv, although this is P, we call it rho, right? This is P is momentum and mv is mass, m is mass and v is velocity. They're asking momentum's units. So mass is kilograms, velocity is meters per second. So that's basically the units, no? kg ms minus 1. Yes, so I gave all, no? Right, we'll discuss. Not all. Hmm. Oh yeah, all. So 10th one, I equals Q over T. So I said for you all to take uh, the unit of current as amperes. They ask in the unit of Q charge, right? So Q will be Q over seconds will be amperes. So multiply amperes with seconds. Ampere seconds is Q, right? And the SI unit was not ampere second. SI unit for charge is coulomb. That also I think I told it's C, right? But here you have to take ampere seconds because like it's derivation of units, no? Because we are still learning. Right. Then we have V equals W over Q. That is V voltage, W is work, Q is charge. What are the units of V? I told you all to take C as for Q in this question. So W is kg m squared s minus 2. Divide by Q. Q is coulombs. So you get kg m squared s minus 2 c minus 1. Right? Yes, you can take it in amperes as well. Then you get like, you divide this by, instead of coulombs, you divide it by ampere second. So you get kg m squared, s becomes minus 1 and minus 2 minus 1 becomes minus 3 uh, per ampere. Right? 12th one, in P equals FV, P is power, F is force, and V is velocity. What are the units of P? So they're asking P directly. So force is kg ms minus 2. V is velocity, ms minus 1. So m into m becomes m squared. S to the power minus 2, s to the power minus 1 becomes s to the power minus 3. Minus 2 minus 1 is minus 3. No? Right. Power is kilogram meter squared per second to the power 3. Right? You can't say per cubic second, no, it doesn't sound that way. Right. Next, for 13th one, no? So kinetic energy is half mv squared. So we don't need to consider numbers. No, it's just mv squared. M is mass in kilograms. V is velocity, and that is squared. M is minus 1 squared. So that becomes kg. Kinetic energy is kg m squared s minus 1 into 2. That's minus 2. Kg m squared s minus 2. Then 14th one, rho equals MOV. That's just basic density, no? So kilograms divided by cubic meter, that's for volume. So kilograms per cubic meter. Right. Then 15th one, they have A equals delta V over T. A is acceleration, delta V is change in velocity, T is time. What are the units of A? Same question, no? Change in velocity is like a difference in velocity. So when you take difference, units doesn't change, no? It's just meters per second. Divide by seconds. So acceleration is, this goes up, it becomes minus 1 as well. Minus 1, minus 1, minus 2. M is minus 2. Acceleration should have the same units everywhere, ne? So then 16th one, you get F equals 1 over T. F is frequency, T is time period. Period in the sense it's time, okay? I should have written time period. So 1 over second is frequency, that is per second. But the official or the SI unit of frequency is hertz. You might have heard it, hertz, right? But using the derivation of units, you don't get hertz because that's the SI unit, no? You get per second. Frequency means the number of like vibrations or oscillations that happen per second. It's like uh, repetitive motions, we call them simple harmonic motions. You will learn them in waves. Let's say the pendulum bob or a grandfather clock pendulum bob again. So that has a certain frequency per second or per minute or per hour. There will be a constant number of uh, like motions, right? Even vibrations are like that. 17th one, E equals HF. Now it has frequency and E. We have to find the units of H, which is Planck's constant. You will learn this in physics in the last lesson, but you will learn this in the, I think, first lesson or the third lesson. I think first lesson uh, in chemistry, right? So H is energy is, you can take joules even here, right? You mostly get it in terms of joules. First we'll do it the normal way. Kilogram meter square. So you need space. Ne? Kilogram meter square per square second into frequencies per second. So one of this minus 2 gets cut with minus 1. Because like when it comes to this side, it becomes s to the power plus 1. Then minus 2 plus 1, remaining minus 1. Kg m squared s minus 1 is h. So if you take joules for energy, joules equals h s to the power minus 1. S goes to the other side, you get per second becomes second. So joule second is the units of Planck's constant. Then 18th one. F is equal to EQ or QE, right? F is a force. They're asking E is electric field and Q is charge. What are the units of P? F is kg m squared, not m squared, kg m is minus 2 equals E times Q. Q is in coulombs. So you get kg m s minus 2 per coulomb. Or if you take in SI units, it's newtons equals E into coulomb. Right? So newtons per coulomb is E. Right, okay, that's all the homework sums. We can go into dimensions. Before that, let's take a quick break because like it's dimensions and deriving equations after that. So it's better to take a break, right? So we'll start at 8:10 again. If you have any questions, you can ask in the chat. Right. We'll start. So dimensions are kind of easier than like unit conversions, right? Because there are only three dimensions that are used for your level, right? So we are kind of relating the basic quantities to a like uh, to the physical quantity to basic quantities using another expression, right? But there we only use like there are no prefixes, right? There are no multiples or submultiples. The dimension is only used. So whether it's meter or kilometer is the same dimension for length, right? If it's time, whether it's hour or minute or second or whatever, whatever the measurement, if it's a time measurement, the dimension is the same, right? You can see the three that we have to see are mass, length, and time. So you know that there are other units, right? Like temperature, so let's say Kelvin, and ampere for current. But there are dimensions for those quantities as well. But we don't have to know about them. So whatever the dimensions that they ask from us will only be using mass, length, and time, right? So there are certain examples that's been given. So if you take area, area is like in meter square or centimeter square or millimeter square. Whatever the unit, it's length into breadth, right? So uh, length is a like a measurement of length, right? So that's in L, that's the dimension of length. And breadth is also a measurement of length. So that's L into L, the dimensions of area, right? So it's L square. So how we say dimensions for a given value, that's like what we say as dimension is we put a square bracket around that value. Then when you put the square bracket, you are saying that the dimension of that value is this. So for area, it's L square. When you take the dimensions of volume, it's length into breadth into height. Height is also a length, no? So that's L cube, right? So there's density as well, right? Dimensions of density. So the square brackets are put in order to show that you are finding the dimensions for this. So density is equal to mass. Mass over volume. Dimensions of mass is M, capital M. These are capitals, okay? And for volume, mass over volume is L cube. So it's M L to the power minus 3. So whether it's grams per cubic centimeter or kilograms per cubic meter, it's ml to the power minus 3, right? Velocity is displacement over time. So displacement is L, time is t. Displacement is a measurement of length, no? So LT minus 1. When you take acceleration, that's velocity over time. So acceleration is velocity over time. Velocity is LT minus 1 over time. Over t, that's LT minus 2. Then similarly, mass into acceleration is force, so MLT minus 2. So there are certain units which have no units, no? Such as relative density, refractive indexes, coefficient of friction, then certain is what we found out. Here, relative humidity, the dielectric constant. These values, these physical quantities without units, if they have no units, they have no dimensions, right? No, you can't say like that. There are units which have no, like most of the units which have, most of the quantities which have no units will have no dimensions. But there are few exceptions. That is plane angle and solid angle, right? Those are the quantities with units but without dimensions. With units but without dimensions. Only plane angle and solid angle, because radian and steradian, right? Radian and steradian do not have dimensions. They have units but no dimensions, right? All other kind of relative values, relative humidity, uh, relative density, all those, they have no units and no uh, dimensions. So if there are no units, there will be no dimensions, but certain values which have units also won't have dimensions. So if you take it like this, you physical quantities can be divided as with units and without units, right? Physical quantity with units or without units. If they don't have units, there are no dimensions, obviously. But if they are with units, most of them have dimensions, but there are some without dimensions as well. That is solid angle and plane angle. So that's a good classification. No? Plane angle is in radians. Okay. If you want, you can copy that down on the side. I'll give you 2 minutes or so. I mean, it's not relevant to the note because it's already there, but it's kind of easier to kind of understand. Right. So now these dimensions can be used in two methods for two purposes. One is to check whether the given equation is dimensionally correct. Right now you can write equations. Now you saw that we had an equation like v equals u plus at. So you can check whether these dimensions match because like for the formula to be correct, the dimensions of V should be equal to the dimensions of U should be equal to the dimensions of the product of AT. We'll get to that. But you can check whether it is dimensionally correct if you know the dimensions of each variable separately, right? It's not deriving the units. You already know the dimensions and you're checking whether the equation is dimensionally correct. So we'll do a few examples to see what I mean, right? And then other one is to derive a relation among physical quantities, right? The other one is to derive an equation using dimensions. Derive like a basic equation. We'll be doing that as well today. Okay, so those are the two uses of dimensions. Okay. So here we can see how the correctness is checked. So if the equation is dimensionally correct, the dimensions of both sides should be equal. And like if it has separate terms which are kind of joined by addition or subtraction, the dimensions of those separate terms should be equal. So here you see A equals B into C plus D over E. So dimensions of A should be equal to the dimensions of the BC product. And that should be the same as the dimensions of D over E, right? Not just individually D or individually E or individually B or C. The dimensions of BC product should be equal to the dimensions of D over E. And that should be equal to the dimensions of A. Okay? Right. So that's how you check the correctness of an equation. So this is the part 2 for derive a relationship from my equation. We'll skip that and go to first see like checking the correctness of equations, right? So exercise 4. Check whether the dimensions of work like this equation is correct, whether work equals force into distance. So take them individually and check. So for work, it's ml squared t minus 2. That should be equal. We don't know whether it's equal. We're checking, right? Force into distance. Force is ml. Force is like, you know the unit now? kg m s minus 2. So kg is m. M is L, right? Here meters is L. S to the power minus 2 is T to the power minus 2. Here also it's kg m squared s minus 2. So m squared is L squared, right? Into distance. Distance is L, right? It's a length, no? So you get on the right hand side ml squared t minus 2. Left hand side also ml squared t minus 2. So left hand side equals right hand side. Okay. Do the second one. Send your answers in the chat. Yes. So pressure is what? It's newtons per square meter. So newtons is kg ms minus 2 into m to the power minus 2. Like for those that don't know how to get it. So that's kg m and m minus 2 is m minus 1 s minus 2. And that's pressure. Pressure equals force over area. Force is kg ms minus 1, right? So you need to put it in dimensions. I'm just writing units, so you all like it's easy for you all to transition, right? So pressure is m L minus 1 T minus 2. Force is m L T minus 2, right? 2 s to the power minus 2. Area is m squared. So here it's L square, not L, M square, it's L square. So you get M, this cuts with one of them and L comes up. So minus 1, T minus 2, right? So it's correct also. No? So let's do this fourth one. So those who have sent the answers are correct. Yes. So no, it's not into T, no? It's work over time. Uh, check the answer, double check it. Right. So let's do it. Fourth one. Power, we got it as kg m squared s minus 3 in the previous question. So that's m L squared t minus 3. That is work over time. Work we anyways put it here. No? So that's ml squared t minus 2 over time. So t minus 2, this goes up, it's t minus 1. So ml squared t minus 2 into t minus 1. So it's minus 2 plus minus 1, that's minus 3. No? Minus 2 minus 1 is minus 3. ml squared t minus 3. So it's the same. It's the same. Ninth one. So this is dimensions, right? Find the dimensions of angular velocity, which is angle over time. Angular velocity equals angle over time. So you don't need to find the units of angular velocity, right? You can just like treat it as a correct equation and get angle over time, the dimensions of angle over time. So angle is radians, right? Radians over seconds, right? So it's radians per second. But radians does not have a dimension. So there's nothing you can put for its dimension. Seconds is t minus 1. So dimensions of angular velocity is t minus 1. It's actually dimension is t minus 1. There's no radian in the dimensions for angular velocity, just as there are no dimensions for angle. So let's do the 10th one. You don't need to find surface tension, the dimensions, like get the dimensions of surface tension. Treat it as a correct equation and find the dimensions of surface tension. So its surface tension is force over length, right? Force divided by length. Force is mlt minus 2 divided by length. So length and length get cut, you get mt minus 2 for surface tension, right? So we'll try another one. Ah, so I'll give you some other sums which are not here. These are just for the next derivations part. Right. So now you have to prove whether they are correct, right? So t, now this is time period, right? equals 2 pi root rho over g. This is density. This is acceleration. This is time period t. You have to prove whether this equation is dimensionally correct. You will have to get both sides correct. So you have to send whether this is dimensionally correct or not, right? So one side it's just time period, so you need to check whether the other side gives time period as well. Give me a minute. Well, send the answer in the chat. I'll be back in a minute. Right. So have you got whether the two sides are matching or not? So here the dimension is also, oh, time period, it's time, right? There's density, which is kilogram per cubic meter, and acceleration, which is meters per square second, right? Root of that. You don't need to take the units for 2 pi, no, it's just a constant. So root means to the power half, right? So meters goes up, that becomes m minus 4, s minus 2, and kg to the power half. So you can clearly see you won't get seconds remaining, no, because here you get kg to the power half, m minus 4, half of minus 4 is minus 2. Half of minus 2 for s is minus 1. So this is not t equal to t, no? So that's not the dimension. The dimensions will be m to the power half, L to the power minus 2, t to the power minus 1. This is not t equal to t. So it is not dimensionally correct. This equation is wrong. Okay? The next sum, x equals a sine omega t plus theta. Ah, yes, it's t plus 1. Sorry. Here it's t plus 1 because s comes up, no? It becomes plus. We have to find dimensions of theta. Not theta, it's actually, theta is this, t is time, omega is angular velocity. So what is the dimensions of theta? I mean, if you remember the theory, you don't even have to find. Yes, it doesn't have a dimension because angular velocity is radians per second. Time is seconds. Per second, second gets cancelled, you get in rad. Rad is dimensionless. So this and this is added. That means theta is also in rad, so it does not have a dimension. So dimensionless means, right? The dimension is m to the power 0, L to the power 0, and t to the power 0. When power is 0, the dimensions of theta, right? 0 means it's 1. It's 1 into 1 into 1, no? So dimensionless means the dimension is 1. Dimension is, like you can say it's 0. It's 1, right? That is what dimensionless means. A is equal to A naught e to the power minus lambda t. Find t. Find dimensions of t. Uh, Dimensions of lambda. Lambda is in per second. Unit of lambda is given in per second. This is also easy. So this is a power, no? Lambda into T is a power. Powers do not have dimensions. So lambda, dimensions of lambda into dimensions of T should be 1, right? So dimensions of lambda is per second. For T, we are going to find now. So seconds goes to the other side, it's seconds. No? Per second goes to the other side, it's second. So dimension is T. Okay, next one. Let's find the dimensions of some unknown quantities. So S is equal to A plus half BT. S is distance, T is time. Find dimensions of A and B. Like A and B separately, we have to find. Yes. So you have to send in like dimensions form, okay? Not in units, right? This is finding dimensions. So S is distance and A should have the dimensions of S, no? Dimensions of S is equal to dimensions of A. Then S is distance, so that is in L. So dimensions of A is equal to L. Then like this half is a number, no? You don't need to consider that. Then again, dimensions of S should be equal to dimensions of B into dimensions of T. That's capital T. S is in L, B times T. T goes to the other side, you get LT minus 1 is equal to the dimensions of B. Right? Half is a constant, no? They don't have dimensions or anything. Another equation, b squared equals au plus bt. So v and u are velocities. T is, sorry, simple t is time. Find dimensions of again a and b. Yeah, one of you have sent the correct answer. Separately, you can find. So v and u are velocities, right? The dimensions of v squared, the dimensions of v squared, right, should be equal to the dimensions of a multiplied by the dimensions of u. So v is lt minus 1 square equals dimensions of a into lt minus 1. So there's one of these, there's two of these. So one of these can be cut with one of the two here. So you get that dimensions of A is LT minus 1. Then you can find B. Again, B's dimensions of B to the power 2 is equal to dimensions of B into dimensions of T. So you get LT minus 1 squared equals dimensions of B times capital T. So you get L squared T minus 2, open the brackets, right? Equals the dimensions of B times T. T goes to the other side, right? It becomes T to the power minus 1. Minus 2 minus 1 becomes minus 3 equals dimensions of T. L squared T minus 3, right? That's for B. LT minus 1 is for A. Because now you can see clearly this is V squared, no? Like velocity square. So here only 1. Then there should be another velocity to make it velocity square, no? So A should have the units of the dimensions of velocity. Okay, we'll do one more sum and go to derivation of equations. S is equal to half B to the power half C plus T into U square, right? Find dimensions of B and C if S is distance, T is time, and U is velocity. Go step by step. It's not a hard question, although it seems like it's hard. First, find for C. Just a hint. Yeah, we'll check. So C and T are added, no? So then dimensions of C should be equal to the dimensions of T. So T is time, then dimensions of C is also time. But now you are multiplying to find the dimensions of B, right? B to the power half multiplied into the time, that is C plus T is like a time, no? Multiplied into U squared is distance. So it's kind of a long expression. So this units of distance is equal to units of B to the power half into, you can take as the units of time, right? Units of time, or even C, like both have the same, no? Both are additions also, no? So they can be taken as single expression. Into U squared, dimensions of U squared should be the, like, that's the equalization. So S is L, B to the power half, so dimensions of B to the power half, into capital T into LT minus 2 square, right? You get L, when you take this T to the other side, is LT minus 1 equals B, dimensions of B to the power half. So you get LT minus 2 square, LT minus 1, sorry, LT minus 1, that's velocity, meters per second square. So you can see LT minus 1 and 2 of LT minus 1. So if you take this to this side, like one of them gets cut directly. So you can cut it here itself. Square gets cancelled and you get 1 over LT minus 1 is equal to dimensions of B to the power half. So get LT minus 1 up, then L becomes minus 1, T becomes plus 1. That is equal to B to the power half. To get rid of the half, you need to power it, right? Like square it, not power it, square it. Half into square. This side will also be squared then. Then you get T squared L to the power minus 2 is equal to dimensions of B, right? So next week I will have to do the class on Friday because I have an exam on Monday. As a result, I can't do on Sunday night. So Friday the same time, 6:30. No, I'll inform the time. It might be like in the evening around 2 or 3 as well. Over the same time, I'll inform you like beforehand. I'll inform you today night. I'll put the message. And also, like, I'll be putting a Google form to, like, uh, Friday will be our last free class, no, for this month. It's the last class. So from next month onwards, it will be a paid class, right? The fee will be around 4,000 per month. Okay. So I'll take like an attendance kind of form just to take whether you're just to confirm whether you're coming to the class from next month onwards, just to take a count. That's like not for any payment or anything, just to get a count whether you're coming. Like the payment is after the last, like the fourth week, right? The payment details will be put after the fourth class. After today, like after this class or like tomorrow, I'll put a form to get confirmation of your attendance for next month, right? Right. We can go to derivations now then. So we'll do the second question first, right? I mean, you can do these for homework, right? These are like really simple examples. I won't be doing them because we have already done most of it. We did v equals u plus at and all that time. You can check their correctness. Right? We did harder questions than that. So now we're going to derive equations by the method of dimension analysis principle. Right? So example one, we want to develop an equation for the periodic time t. Right? Periodic time t. Periodic time t of a simple pendulum. So that's time, no? The dimension is t. First, we have to experimentally or logically, it should be logically identify the quantities related to periodic time. So they are usually given, right? Consider that the time period depends on the mass of the pendulum, the length of the pendulum, and the gravitational acceleration. So when there's a pendulum like this, there's the length of the pendulum to the center of gravity, there's a mass for it, and there's g also. So separately you can show their relationship. So like the time period will be proportional to, we don't know whether it's directly proportional or inversely proportional or whether it's proportional to a power. So we put proportional to m to the power x. So x can be either 0, whether it might not depend on this either, right? So it can be 1, 2, -1, -2, right? So if it's inversely proportional, it's 1 over m, no? That's m to the power -1. So I'm just saying it can be many different things. That's why we put x. X can be any number. It can be a fraction either. It can be half. That means it's a root. And we can write again t proportional length of the pendulum. But for length, it's not the same power, right? We don't know that, whether it's the same or not. So it's L to the power y. And t proportional to gravitational acceleration. That is g to the power another power. That's z. So if it is separately proportional or depends on these three values, we can take them together. We can take their multiplications. So if T is separately proportional to mass, length, and gravity, it should be proportional to their product as well. So it's m to the power x, L to the power y, and g to the power z. So we can equalize by using a constant k. Now, for this dimension analysis principle, the constant doesn't actually have units or dimensions, because if it did, we have to find the units or dimensions for that constant also, no? So, dimension analysis principle can also only be applied for constants which have no units or dimensions, right? So, t equals k, that is the constant, times, just to equalize, we are putting the constant. We don't really need it. M to the power x, L to the power y, and g to the power z. So we can write for both sides the dimensions, right? We are writing for both sides the dimensions. So now the dimensions of the time period should be equal to dimensions of mass to the power x, dimensions of L to the power y, and dimensions of G to the power z. Then in this side, there are other two dimensions as well, mass and length. Now this is time. So mass, it doesn't depend on mass. That is m to the power 0 and L to the power 0. Doesn't depend on the length in the, yeah, like time period is time, no t to the power 1. So for it's the power of the mass dimension is 0, and for length dimension also it's 0, right? Then like this is 1, this is 1, 1 into 1 into t to the power 1. Again you get t, right? But because we have m and we'll have m and L on the right side, like we have to get it on the left side as well so that we can equalize. Like, so you'll understand when we do it now. So m, that's mass, right? So m, capital M to the power x, length L, that's capital L to the power y, and g, gravitational acceleration. Acceleration is LT minus 2, right? LT minus 2 to the power z. That is L to the power z, t to the power minus 2z, right? This is not minus 22, it's minus 2z when you open the brackets. So now again you have to write it how. So it's m to the power x. Now there are two l's. So L to the power y plus z. The powers are getting added. And t to the power minus 2z is equal to m0 L0 t to the power 1. So you can see for m, right? For m, x should be equal to 0, right? X is 0 because like this should be equal to this, no? Otherwise you can't get that equation. So x is equal to 0. And for length also you can equalize on both sides. That is 0 equals y plus z. Then you get minus z equals y. Just keep it at that. Then for t also you can equalize. 1 is equal to minus 2z. Then minus 2 goes to the other side. It's minus half is equal to z. Then z is minus half. That means you substitute minus half for z. So it's minus into minus is equal to y. Y is plus half, right? Then you can rewrite this equation. T is equal to k to the power, now m to the power 0, no? M to the power 0, L to the power half, and G to the power, Z is minus half, no? Minus half. So minus half, like when you get it down, it's plus half. So you can write k, m to the power 0 is 1, you don't need to write it. So t equals k, L to the power half over G to the power half. Again, you can write it as k. This is, for both of them, it's root, no? Root of L, root of G. Root of L and root of G. So k times root L over G. That is time period. The constant has no units here. So just for your like information, the constant is 2 pi root L over G. Time period is 2 pi root L over G for a simple pendulum. We will be learning these equations in our waves lesson, right? For now, we just need to know how to derive a basic equation where the constant doesn't have any units. So you can see, 2 pi doesn't have a unit. 2 pi is value, Okay, you can copy this down, right? Then we'll go to the next one. And if you have any questions, you can ask. So in the attendance confirmation form, just there you will be asked whether, I mean, there'll be, you can select whether you would like to attend physically or not, right? It will be in Colombo, anyways, if it is physically. But it depends on like whether the majority likes physical or online. So just select what you like when you're filling the attendance confirmation, right? Fill it only if you plan to come from next month onwards, right? Not to the next class, from next month onwards. Right. Shall we go to the next part then? We all try to do this by yourself, then we'll check it. So for you can do these questions for homework and we'll check them next week. Exercise 5, there are 1, 2, 3, 4, 5, 6, 7. Do this one. When a stone is tied to a string and it is moved in a circle in a horizontal plane, you don't really need to think about what happens here, right? You just need to get the derivation for the equation. We can assume that the tension force F gained by the string depends on the mass of the stone, speed v of the stone, and radius r of the circle in which it moves. Obtain an expression for tension F, that is a force, right? Using dimension analysis in terms of above quantities. Consider the proportionality constant as k. Send your answers in the chat. I think we can discuss. No? So, tension force F gained by the string depends on the mass of the stone, speed V, V to the power Y, and radius R, R to the power Z. You can take ABC as well, okay? It doesn't need to be XYZ. So tension force will be proportional to M to the power X, V to the power Y, and R to the power Z. F equals K times Mx, Vy, and Rz. Then we get, so now we just have to equalize, no? Dimensions of F is equal to dimensions of M to the power X, V to the power Y, and R to the power Z. So dimensions of F force, no? MLT minus 2 equals mass M to the power X, velocity LT minus 1 to the power Y. Velocity is meters per second, that's LT minus 1. R is a length, so it's L to the power Z, right? So here you get M to the power 1. Here you don't need to get zeros like all three are there, no? So M to the power 1, L to the power 1, and T to the power minus 2 equals mx. Here you get L to the power Y, right? L to the power Y plus Z. Sorry, Y plus Z, no? It's L to the power Y and L to the power Z. So Y plus Z. T to the power minus Y, right? Okay, no? Right. So directly you can equalize X and 1. X equals plus 1. Then you can equalize T and Y. T is minus 2, Y is minus Y. So Y equals 2. And L is 1. 1 is equal to Y plus Z. Y is 2. Then Z will be 2 goes to the other side. 1 minus 2, it's minus 1. Then you have the 3. You can write F equals K M to the power 1, that's just M, right? V to the power 2 and Z to the power minus 1, that's R to the power minus 1. So you can actually put R below mv squared over R. This is actually a real equation. Here the constant, the value of the constant is 1, like in the actual equation, right? We don't have to know how it becomes 1. So F equals mv squared over r. That's the that's the circular motion equation that we learn in mechanics. Right now you have already derived it. So now we can just apply it when we come to circular motion. Right? We'll do another question and then we'll stop for today, right? We can now we have finished units and dimensions, right? Just 3 weeks, right? And we have completed everything with a lot of questions as well. So like I hope you have gone through the plan that I have sent. So like according to that plan, we can finish the syllabus easily while doing past papers and questions with, before 5 months before the exam. So if you work properly also, then like A-level physics is nothing if you work that like according to a proper plan, right? It doesn't need to be a strict plan, but just a general deadline and like uh, a good class that will help you finish the syllabus in time helps a lot. I mean, that's what I can say from my experience. Okay, we'll do another question. Which one will we do? Let's do the seventh one. Fourth one we already did, right? Time period of a pendulum. Let's do the seventh one. Here the equation is already given. That's a bit of, right? T is the periodic time of an air bubble oscillating in a liquid. Expression for T is given by T equals minus uh, P to the power A, D to the power B, and E to the power C. P is the pressure, D is the density of the gas, and E is the energy. We have to find the values for A, B, C. Here, just the minus is like it's coming from a constant, okay? Don't put P down and say it's now plus. That power minus and this, the minus in equation doesn't work like that. Try this, I'll give you 5 minutes. Yes, one of you have sent the answer. What about others? Now, by now you know the method, so you have to send the answer. So they have already given this, no? T equals minus P A d density to the power B and energy to the power C. So dimensions of T is equal to dimensions of P to the power A, dimensions of D to the power B, and dimensions of E to the power C. So here also it's time. So M and L will be 0. T is 1. That is equal to P pressure. Pressure is what? It's force of area, no? Pressure. We even found it out previously as ml minus 1 t to the power minus 2. Or you can take it from here, ml t minus 2 over L square. So you get the same thing. ml minus 1 t minus 2 to the power A. Density is kilograms per cubic meter. That is m. Meter cube is L cube, that is per cubic meter, no? To the power minus 3 B to the power B. And E is energy, that is ml square t minus 2 to the power C. But open the brackets for everything now. M to the power A, L to the power minus A, t to the power minus 2A times m to the power B, L to the power minus 3B dot m to the power C, L to the power 2C and t to the power minus 2C equals m0, L0, t to the power 1. Then we have to add these m and m. M equals A plus B plus C, right? Then for L, it's minus A minus 3B and plus 2C. Minus A minus 3B plus 2C. Then for T, you get T to the power minus 2A minus 2C. Right. So it's a very big one, no? We'll use this side. So for M, it's 0, no? A plus B plus C is 0. And for L also, it's 0. Minus A minus 3B plus 2C is also equal to 0. You can add these two if you want, no? Both are 0. No? You can add them. Then you again get 0 anyways. If you add them, A minus A is like it gets cut. B minus 3B is minus 2B. C plus 2C is 3C. So 3C is equal to 2B gets sent to the other side. It becomes plus 2B. C equals 2 over 3B. Right? C equals 2 over 3B. Then for T, it's 1 no, this side. 1 equals minus 2a minus 2c. We can substitute c as 2 over 3b here. So you get a minus 3b. Sorry, not minus 3b. A plus b, no? A plus b plus c. That is 2 by 3b equals 0. So here common denominator 3, this multiplied by 3. So 3 plus 2, 5 over 3b. A plus 5 over 3b equals 0. Then you get a equals, b gets sent to the other side, minus 5 over 3b. Right? So you have uh, a and c both in terms of b, no? You can substitute it here. 1 equals, you can actually take the minus out. Both of them are minus, no? So I'm going to put minus 1, right? Minus 1 equals 2a plus 2c. Minus 1 is sent to the other side. Both have minus. So minus 1 is equal to 2a. That's 2 times minus 5 over 3b. This one. Plus 2 times c. Right? C is 2 over 3b. So it's actually here 5 into 2, that's minus 10. Plus 2 into 2, 4 over 3 equals minus 1 into b. So we get minus 1 equals minus 10 plus 4 is minus 6 over 3 ne? Into b. So minus minus gets cancelled, and here it's 1 equals 2b. 1 equals 2b. Then b equals half. B equals half. Then you can substitute b equals half here. C equals 2 by 3 into half. 2 and 2 gets cut. C equals 1/3. C equals 1/3. Then also you can substitute b in a. This one. A is equal to minus 5 over 3b. That is half. So a is minus 5 over 6. So we have everything now. So we can write t equals minus p to the power a, that is minus 5 over 6. D to the power b, that is half, root d, no? E to the power 1/3. So you can keep it at that because 1/3 is cubic root and this is root, no? And 1 is minus 5 over 6. So that's a very good sum to practice. You can do this again at home, right? Do the sums that we have done again throughout these 3 weeks to kind of recap the whole lesson and see whether you remember everything from top to bottom, right? That's a good question. You can do the other 5 for homework. Has everyone like copied this down? Should I keep it? Okay, so we will stop the class for now, right? For today. Friday is the final class for this month, and that is also free, right? I'm just putting a form to get an idea of the count that will be there for from next month onwards, right? And the fee will be 4,000 per month. And you will have to like feel whether you want to attend physically or online, the physical time won't be at night, right? It will be in the evening, like 2, 3 around. But it depends on how many of you all want a physical class, and like depends on the number of students that are confirming the attendance. So I put the measuring instruments tube test well because for next day we have to start vernier caliper now. Yeah, so that's it. Any questions? Okay, if there are no questions, then we will stop for today. I'll send the recording as well, right? Okay, have a nice day then. Good night, everyone.